Ladies and gentlemen, it is June 8th, 2016. This is the Daily Code, and I'm Chris, or assertchris, on Twitter and Twitch. And today we are continuing what I started yesterday, which is to make a real-world alarm for a Minecraft house. So yesterday we built the detection for open doors in Minecraft and connected it to a PHP script, which gave us feedback in real time when the door was opened in the game in a PHP context. Today we are looking at hardware for this. So we are I've got an Arduino here, and so there's a story behind why I started late, and it is because I was trying to set this camera up for literally hours. And this is the best that there is. It's a little blurry, but hopefully not too blurry that you can't see completely what's going on. And with any luck, this will be useful to you and refreshing to me to do. Now, I've done quite a bit of Arduino stuff in the past, but in the last year I've not touched it at all. So there's a good chance that I'm going to be very rusty at this. Anyway, you can pick an Arduino up at any number of places, including online shops like SparkFun. You can buy it from there. Let's see. And there's a huge selection of these, and actually quite a large variation of boards that you can buy. So this is the one that I've got going here. I think I've got the R2, if I'm not mistaken. I don't remember. I got the second hand. But you can get one of these compatible ones, you can get minis, you can get, let's see, what other ones have I got? So I have one of these official boards, and then I have a couple generic boards, and then I have one micro, I think, but I don't see it on the list here. Anyway, you can pick these up from SparkFun. They're not actually too expensive considering the fun things you can do with them, and I highly recommend it if you want to get into making things with circuits. Then Arduino is a really cool place to start. It's a really good learning curve, and there's a lot of good software around it and a huge community. Anyway, I've plugged this Arduino in, and that is about all I have done. To get started, head over to arduino.cc and click the download link, and then you can pick for your platform. It works on everything, which is pretty cool. I've done that. It's about 140 meg download for Mac. So I've done that and started it up, and the IDE looks like this. In fact, I've gone one step further, in that after I plugged the Arduino in, just to make sure that it actually worked, because I haven't tried this one out yet. Before this, I went to the menu. Now you can't see mine because it's on a different screen, but if you go to the file menu, there's actually an examples option, and you can go examples, O1 basics, blink, and it will pop up this bit of code here. Oh, it's gone and resized it to a different screen. Okay, so it'll pop up this code example here. This is a good way to test if your board is actually working and connected. You'll also have to go to the menu to tools, board, and then pick the right board to match what you have in your system. So if you look down here, it says Arduino Genuino Uno, which is the board that I've got plugged in here. So if you get a Nano or a Yun or whatever, you just select that board from the tools menu. And then you'll also have to select from the menu the port that we're using. So the one on Mac that this is plugged into is this port down here. If you don't select those, let me see if I can unselect them. No, I can't unselect them, unfortunately. But if you don't select those, when you hit this upload button, you're going to get an error. But because I had selected them, it uploads successfully. And you'll see some rapid blinking going on around here as it uploads and as it restarts the Arduino. And after that, you should see this blink. Now, I already uploaded it, so if you look closely over here, you'll see this blinks on and off. To show you that this is actually working, I'm going to reduce this to blink 4 times a second and upload that. Notice this blinking going on here. And there the blinking is a lot quicker. Let's slow it down, like quite a bit. 3000, and upload. Some serial blinking here. There we go, on for 3 seconds, off for 3 seconds, on for 3 seconds. Okay, so we know this is working. We know that the Arduino is connected via USB, that we can upload this variant of C code to it, that we can start to affect things with this. Now, I'm not going to save changes to that because it's an example, but when you open the editor up, this Arduino IDE that you downloaded, you get this. And the comments tell you what these specific functions are for. If you're not familiar with C, if you're familiar with JavaScript or with PHP, these are just functions. Setup gets run when the device boots. So here you can set up variables to, you can set modes for the input and output pins along these sides. And then in loop, this happens for each clock cycle of the Arduino. I think it's something like 8 megahertz or 16 megahertz, depending on your version. Anyway, the idea is that you do all your setup within this first function and all your continuous checking for input and setting of output in this loop function. So if we go back to the example, which I closed sort of prematurely, we have a look here. Let me bring it over here. Okay, so the setup that's being done in this function is to set pin mode 13 to output. An Arduino has different pins for input and output, and depending on your model, they're at certain positions and they have certain interesting characteristics. The Uno has, let me just count them quickly, six analog pins, which means pins that can have an output variable between 1 and 255. And the rest are digital pins, which means basically on or off. And so when you want to do things like detect a button press, you would pick one of the pins, preferably a digital pin that has an on and off state, and you would set that pin mode to input. And then you would read from that pin, and that way you would detect whether the button was pushed or not. If you wanted to power an LED, you could connect it to a digital pin and it would go off and on with no variation in between. Or you could connect it to an analog pin and then you could scale the variation in between. So you could make it fade in and fade out. That's the basic unfiltered difference between the digital pins and the analog pins. Now, for our experiment today, we're actually going to try and connect a buzzer to this. So let me have a quick look in the examples if there is an example for buzzer. Analog read signal, blink, digital read signal. Let's see, digital. No. Okay, so we're basically going to have to work off of the blink example, I think. And we may even load up an analog, something that has analog in it as well. Examples, analog, fading. Okay. Okay, so here we have two sketchbooks to work with. I'll actually just tile them so that I can, come on, clip. I'll just tile them so that I can scroll between them. So this is the blink example that we had. It's a little bit behind the overlay of the Arduino. I apologize for that. And I'm not really happy with the overlay of the Arduino, but I'll spend another few hours and try and green screen that away, mostly. I was almost there, but I don't have enough lights, unfortunately. I've already got 3 on the green screen at the back, and I don't have enough focused on the hardware itself, so I'll have to get some more lighting, I guess. All right, so contrast this. We set. Oh, I didn't explain this. Okay, so you know the example that we have that turns the light off for 3 seconds. Let me just upload this again so that it's back to 1 second. Some blinking, and then we go on for a second, off, on, off. Okay, this example code that turns that on and off. Window snapping. This example code that turns it on and off is turning it off on pin 13. And the reason it's blinking is that there is an LED connected to pin 13, so that you don't have to set up your own LEDs to test whether it's working immediately. You can just write to pin 13, high and low, and it will toggle this LED. It's a quick way of debugging without having to connect extra hardware, which is pretty cool, I find. That explains why we can set the pin mode on this. This is frustrating. Why is it doing this? Hold on. Let me go to settings and see if I can change this around, because this is really annoying. Mouse. Is there a way for us to toggle this so that we don't have so that we don't drag windows to resize them? It's pretty annoying. I'll have to try and figure that out later. Anyway, that connection between 13 and the debugging LED means we can just set the pin mode and write high and low values to it as a digital pin, and it will go on and off. We can do that without plugging in LEDs of our own or other components of our own, so that we can get immediate feedback as to what's going on in the circuit. Okay, now contrast this with an analog example. We've just moved where we set this, where we set the pin number, but on the Uno pin 9, you'll see if I move this a lot closer to you. Can you see? Can you see? Oh, it's very blurry. That was another thing, trying to set the camera up to work on Mac OS. It's a pain. Okay, anyway, pin 9 has a little squiggly line next to it, and what that line says or indicates is that pin 9 on the Uno that I have here is an analog pin. And they actually follow this. I don't have my nano around or my micro around, but they actually follow this convention. So if you see a pin number with a squiggly line next to it, that's an indication that it's an analog pin on the Arduino. Anyway, we don't need to do any setup for that, but we can do an analog write to that pin with a value. So here it goes from 0 to 255. It's going to fade in, delay for 30 milliseconds, and then fade out. Now, I don't have an LED at hand. Well, I do have LEDs, but I actually don't want to mess around with them. Take my word for it. This actually works. And, okay, so back to our project at hand. We want to do a real-world alarm for a Minecraft house. So I got a buzzer like this. There was actually a Comic-Con in the town that I'm in. And this electronics shop called J-Car, an electronics chain in New Zealand, were selling components, which was pretty fortuitous, because I knew that I needed to get one of these buzzers for the experiment that I wanted to run today. So let me unbox it very messily. Okay, let me unbox it and then we can take a closer look. Now this is a pretty simple component. If you look at it, looks like this. I'll move it pretty much closer. There you see, it's just got 3 pins coming out of it. The trouble is, I don't know what those pins are supposed to mean, and I threw the box away pretty prematurely. So I've got to try and figure out. I've got to try and figure out what this is now. Let's see. Let's minimize these and have a look here. Arduino Tech Active Buzzer Module. Doesn't have that part number on, but it does look like that. Interesting. Okay, so how do you plug this in? Let's take this and put it right in here. Okay, so speaker pin. Looking at the Arduino, I think I need to get some jumper leads out to connect the speaker. So luckily I have a big box of all sorts of ugly jumper leads here. I'll get a purple one. There we go. Okay. So I'm guessing that's the pin that I need to connect to ground. So let's do that. Okay, and then I need to connect, sorry, let me move this a little bit in so that you can see I've connected the one pin to ground. And then let's connect another pin. Maybe I'll make it orange. Do I have a sealed orange jumper? What a messy collection of jumpers this is. Wow, wow, wow. Blue. It shall be blue. Okay, this one I will connect to 8, because that's what the code listing has. Let's see. All right. So the speaker pin is set to 8. We set the pin mode of that speaker pin to output. It is a digital pin, which means that's actually high and this is actually low. That doesn't make any sense. I'm going to connect this to 9 and change the code listing to reflect that. Okay, let's try that. This may make a lot of noise, and I apologize if it does. Sure, why not? Please don't blow up. There we go. Do you hear that? Ooh, table is showing. Oh, it wasn't making a proper connection. There we go. Do you hear that? That means it's working. Okay. Oh, it's not going to go away, is it? Okay. Now, what this shows us is that we can connect to this little buzzer module. We can plug it into an analog port and ground based on the pin configuration there. Oh, I actually think this will be louder if I take that off. Let's see how loud this is now. It's probably going to be very loud. Yes. So that should be much more audible now. Wow, that's interesting. So the analog signal that you send through there changes the tone of this. What if we look at the fading example? Everything inside the loop. I'm not used to this IDE at all. Okay, what if we do that? And we change these references to speaker pin, and we upload this. It should do. Okay. I mean, it's a horrible noise, but it's interesting. It's interesting that you can change the tone like that, just based on the analog signal strength that you give to it. Anyway, that's cool. So we've got this working. I guess the next step is for us to connect it to PHP. So I think for that we need to go to GitHub. I remember there being a really good serial library extension for PHP called Gorilla. PHP Make, I think, was the organization. The user PHP Make serial port. Okay, yes, so this is the, is there a website behind this? This guy does a lot of really cool hardware-based PHP stuff. Unfortunately, I can't read Japanese. So let's go and clone this. Let's see, no, I've already got a directory for this. Minecraft, clone that. So we have to clone this, and we have to build it as an extension, and then we have to link that extension. We have to move it to extension directory and link it in PHP INI. So let's go in there and just copy the commands out here. Do I have? Oh, I do. There we go. Silly me. So we'll do that and configure enable Gorilla. So that's a good suggestion. Carica Fermata. Thanks for that suggestion. I've seen this before, but I don't remember. I don't remember what my experience was with using this. How does this not need an extension? IO event loop factory. Is this based on? What is powering this? React? Wow, that's really cool. Actually, I'm going to try this. Forget the extension. Forget that extension. Thanks for the suggestion. Okay. So that command is composer require. And then rmrf, the Gorilla extension. You see, I've tried the Gorilla extension. I've tried the Gorilla serial extension before and had great success with it. So it's kind of what I've run with in the past, but without having, not having to install the extension. It's actually pretty cool. Not having to install and compile. Oh, why so long? I'm blocking IO for PHP. So many of that. Anyway. Oh, lame! Okay, let's remove that and open up an editor for this. I'm probably going to have to set the minimum stability of this. Yeah, 0 releases. Oh, okay, it's not a problem. Let's see. Minimum stability, dev, prefer stable. Hopefully we don't wait this long this time. What version of PHP am I using here? 6.5.6. You have mail. Okay, so this is the PHP Minecraft stuff we did yesterday, which was basically a file watcher for the log file to intercept messages triggered by the circuitry that we had in the Minecraft map. And we'll go back there now, in a little bit. But we essentially want to do the writes within these areas here. So with any luck, we'll be able to connect to our Arduino. Let's see. Examples. Oh, I need to install Fermata. Okay, so this is another thing. When you want to start interacting with the Arduino via a serial port with software controlled by a computer, like this laptop that this is plugged into, there is an API of sorts called Fermata. So where would that be again? I'm just got to find it. Okay, Fermata standard Fermata, I think, is the version that I need for this. So if I upload this to the board, it's no longer going to be running code compiled through the Arduino IDE. It's going to be running the Fermata API through the board, so that software on a computer this is connected to can interact with it. Hopefully I've done that description justice. Okay, so let's put all this IDE stuff away and let's have a look at what this is doing. What does this actually do? Oh, this hosts a server to interact with it. Never mind, that's not actually what I want to do. Let's do Blink. Blink is the simplest thing, and we've done the IDE version of it. So let's just make a new file here to isolate this process. Blink. There we go. So we actually need to load. What does Bootstrap have in it? I'm going to copy this directly. Okay, and then let's go to our composer composer autoload stuff over here. Okay, so we'll read through this. Alias some things, include configuration, which is another thing I need to include. Sigh. Okay, I don't need all of that stuff. So I'll do that, and I'll pull this stuff out. Oh. Fermata mode. Serial DIO is what I want here, I think. Serial device, serial board. I'm not really sure which is the best option here. And also the formatting is not the best. But anyway, okay. So let's ignore that for the moment, and let's bring up the serial port number that we have here at /dev/cu.usb modem 141. Okay, and let's just define this underneath here, because I'm not defining it via includes. Okay, that means that it is going to run this branch, and it's going to use the device and the board that we've got configured over here. So for the sake of being absolutely sure what code is run, I'm just going to comment out everything I'm not going to use. Oh, board is that. In fact, I will even well, see, I want to be able to uncomment the stuff if I need to. So I'd rather say board is equal to that and comment that out. Okay. Let's just make sure that this is working. So PHP blink. I was already there. I'm including it twice. I'm including it twice. Oh, minimize this nonsense. Invalid serial port. That's interesting. Okay. So let's try this instead. And if it works, I'll explain why I thought that it works. Okay. Well, the device is mounted in /dev, and this one, this matched or was similar to the port name in Arduino IDE. However, I don't see. Okay, there I see the CU one. I have no idea why the TTY one worked and the CU one didn't. I don't actually know enough about system architecture or device mounting to be able to tell you why. It was just a guess. So if you're not having any luck matching them up, try the TTY version of it. Okay, fine. Okay, fine. So we've got a board instance there. Let's see what happens when we run the rest of this. Interesting. So it's not blinking. Has it given me... It hasn't given me any kind of... It hasn't gotten here. So it doesn't find it if I use that previous version. Let me have a look if board is specified anywhere in here. No, it's not. Okay, that's interesting. Let's try instead one of the other. Let's try one of the other connection mechanisms instead. This is just a lot of trial and error so that I can get basic feedback from the Arduino, and when I do, I will be a lot happier about life in general. Let's comment this out. Board is that. Oh, also need changes to serial DIO. Okay, that didn't work, but let's change this back to TTY. So much trial and error. That's interesting. What did the original code have in it? Mr. AFK, did the basic Fermata examples work out at all? I'm still trying to get the basic Fermata examples to work out. So there's that. Dev TTY 0. Yeah, I'm still trying to get the basic examples to work out. This is the device that this successfully connects to. However, it's not getting to the point where it'll actually connect. If that makes sense? Okay. Let's just restart it again. That does connect to the device. However, this never executes. Maybe we need something other than the standard fermata uploaded. Oh. Let's try uploading that again. So what I think happened there was that I was connected to the Arduino through this PHP script, and I tried uploading, but the connection was already open. Let's try it again. Could not connect. Let's close this. Wow, I just closed everything. Have you tried unplugging and plugging it in again? Okay. So we re-uploaded standard fermata, but again we are not getting to this activation state. So curiouser and curiouser. Okay, let's see what other variations of fermata I can upload to the board. That's going to be my next attempt at solving this. Let's see. Close this. All these open. Okay. What am I? Oh. That's hilarious. The last window you close of Arduino actually shuts the app down. It's good to know. And we are having a bit of a longer first segment because I really want to get the standard fermata stuff to work. So standard fermata plus. What's fermata test? That's interesting. Never mind. Fermata, standard fermata plus, no idea what the difference is between the two. But let's see if it works. Okay. Board's restarted. Ooh, updates available for some of the libraries. What are these updates? Okay, is this busy? Sorry. Busy. Busy. I wonder if running this through a USB hub is causing issues with it. I wonder. Maybe I should try and run this. Okay, I'll tell you what I'm going to do. I'm going to take a quick break because this is frustrating me. I will be back in a couple minutes once I've plugged it directly into my laptop, and then we shall try some more. So hang around for a bit. I will be back shortly.